thanks for joining us. In this installment, we're going to actually look at being able to easily change connector parsings when you're out in the field. So quick and dirty changes you can make to a smart connector or a flex connector, which allow you to basically do this pretty much the same job as what we call a parser override. And traditionally a parser override has been almost, well, the easiest thing to do out in the field as opposed to writing a full flex connector yourself. So let's say you've got a Cisco PIX firewall or a FireEye box or something like that that just doesn't quite do what you want it to do, or you've got a custom firmware on your particular site and you need to shuffle some fields around or concatenate a field or something like that. Something simple, something that you would do in a parser override, but you don't have the resources to actually get hold of the unobfuscated parser and actually make those changes. So a little bit of an agenda. What's the problem we're actually solving? What do we do? What exactly is an expression setter, and how can I actually use them? So I'll give you a bunch of examples. Then we'll go through and do an actual real demonstration of it using some FireEye logs, and then why is it important and how we can get the most value out of it. So what is the problem? If we're wanting to just make a slight change, I just want to pull out certain parts of a fully qualified domain name. I just want the domain name, and it's not coming through in my events. I just want the last 4 digits of a credit card number or something like that. I just want the host of a FQDN, for example. In the past, up until, well, it's well over 12 months ago now, for both smart and flex connectors you would use what's called a parser override, and they've always been a little bit mysterious because to do a parser override you basically need access to the unobfuscated or plain text parser from support, and that was done on a case-by-case basis because at the end of the day ArcSight connectors are part of our IP, and a lot of work goes into maintaining and building the smart connector framework, so it's not something that's made easily publicly available. If you manage to get your hands on a parser in plain text format, you then need to understand it, and some of the parsers are actually very, very complex and more so long-winded than anything. Cisco PIX, some of the Juniper stuff, etc. They're really, there's a lot to them, and then you need to actually generate your parser override, find out what you're actually doing. In parser overrides, I'll actually be covering that off in another tutorial. Just have a look in my channel for that particular tutorial. But and then you need to put files in particular places and so forth. Now, in the case of ESM and Express, you can basically just create a filter with local variables and actually view and basically extract what you're looking for with the use of a filter in an active channel. Now that's okay from a viewing perspective, but you're doing the massaging of the event after it's been processed and sent up through to ESM or Express. So it's not the perfect it's not the perfect solution. We want to be able to do this back at the event source, so then we can store it long term in Logger and research for it later on, or send it off to another system, for example. We've got to keep in mind that the connector framework in a good deployment will do as much of the processing and work and the grunt work as possible. Take the work away from your log management and your ESM tier. It's very important because at the end of the day, the connector framework just needs processing power. So in terms of cost and TCO and ROI and so forth, put what you can in the actual connector framework. It's a very valuable way of doing the processing in a very cheap manner. So expression setters, this came about as with the release of the Smart Connector Framework 704 over 12 months ago now. So basically a whole new set of operations that we can use to change fields as they're actually filled in. Now they're in addition to map files, and we'll go through map files in a separate tutorial. Again, have a look in my channel. I'll be adding a map file tutorial very shortly. But map files have been around for over 10 years. The Smart Connector Framework and Ceph is extremely mature, so there's a lot going on, and it's rather interesting how so far down the track we add this new capability to sort of negate the need for parser overrides, because it is a much easier way of doing it. There's two directories and two files. One is done before DNS and the other one is done after. We're going to concentrate on the one that's done after DNS. Now these new operations within expression setters can be made, it can work with smart connectors as well as flex connectors, so that's very handy as well. So as an example, server.domain.com, let's just pull out the host name and just replace it with server. We could copy entire contents of field A to field B, or just parts of them and so forth. We can concatenate, we can do regex and so forth, so there's a lot of flexibility there. So what's the general format for a map file? Well, you've probably seen these in the past. These are floating around the ArcSight framework, the ArcSight Smart Connector framework everywhere. It's all about what we call getters and setters. So the first piece gets the value that we're interested in. In the example here, you can see event.destination port, and then the second piece, or the piece after the comma, is what we want to set something to. So as you can see here, this is a nice little value add that you can do to your events, and say, okay, well, if I see destination port equaling 23, I then want you to set application protocol to telnet. The same thing goes for 80. If my destination port is 80, then set my application protocol to HTTP. Great. It's just a nice way of enriching the information it's a rather static way, but if we wanted to do it in a more dynamic fashion, we would use what's called external mapping, and that's another tutorial I'll run through. So again, check my channel for a video tutorial on external mapping, which is separate again. So it's a more dynamic way of achieving the same thing. But expression setters go a little bit further, but the new value can be based on the old value and so forth. So it's all about, as I said before, these getters and setters. So what we need to do is basically say, what field are we going to use to set, and then the next field we actually want to set it to be. Now, you might be able to see this where we say set.expression device vendor .event device vendor, and then set the device product to device product. And in the second line is our setter, just like our other map files. So what we're doing here is we're replacing the device vendor value with an uppercase value, an uppercase version of the device vendor. So we're saying set my device vendor to an uppercase, comma, I also want to set my device product to an uppercase. So in other words, we've got multiple getters and multiple setters all in the one file. So it becomes rather handy. You've got to write out the transformation and additional parsing you want to do. You've got to write the file and place it in where it needs to actually go. Now, for classic map files, you've got two choices. You can either restart the connector, or you can wait 5 minutes. Your choice. However, if you do the post-DNS version of these expression map files, you've got to do it. You've got to do a connector restart. Not a huge big deal, but just be wary of that. Where do I actually place my files? In the classic old map file, which you're probably familiar with, you're operating on the events before DNS, early on in the event flow, and they simply go under current user agent map, and they are sequentially labeled files, map.0.properties, etc., all the way through for as long as you like. Whereas in the case of expression mappers, we're actually doing it under current user agent AUP ACP. Now, when you install a connector for the first time, the AUP ACP folder won't exist. You'll actually need to create those. So don't think that directory will already be there. Don't think you're in the wrong place. You're not. You actually need to create those files. So slightly different file name: agent info adder 1.map. .10, .11, etc., .12, .13, etc., 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 and on it goes. So you can do lots and lots of these map files to do, parts of the tokenization and remapping, and then the next file can do the next piece and so forth. So they can build upon each other, or they can be mutually exclusive. So let's take an example of where we want to simply remove server 22 from server22.whatever.com. So what we can do here is you'll see set.express device host name. So that's what we're actually interested in as a getter, so to speak. Sorry, as the getter. And then what we want to set it as is going to be a regex token, and you'll know from the FlexConnector development guide that your first parameter into regex token is the source piece of information, which in our case is device hostname server22.whatever.com, and then we've got a little piece of regex in there that basically is saying while not it's basically while not a full stop, grab everything. So what that means is it's going to hit the S, yes, keep going, E, yes, keep going, all the way to 2, then 2, and then it's going to get to the first full stop and then stop. And it's going to return and put into device hostname server22. Everything else, where you can see .* or .*, is going to be discarded. So that's an example of a regex token where we might just want to grab part of a field. Now, again, traditionally you do this in a parser override, but this is one way of achieving it, literally with a smart connector, and you can drop these little CSV files in, write them yourselves, drop them in, and suddenly you've got yourself a smart connector that's doing more than what you bargained for. So there's lots of different things you can do. As I said before, take pieces of fields, concatenate, regex token, all sorts of different things. It's really up to you what you actually want to achieve. Now, the only thing that you really need to be aware of, and where I see most mistakes being made, is around the use of double quotes. Double quotes is it takes a little bit of practice. Using the double quote characters, using the backslash, backslashing the backslash, etc., etc. So most of your issues in that regard will be caused by quote characters and so forth. So be wary of that. Make sure you've got plenty of examples on hand, and I'll certainly be showing you several examples so you can get a feel for how it should look. And once you've done it a few times, you'll be fine. So in actual using them, there's, as I said before, they're just sequential files, and as I said, .0 could do some work on the event, .1 could then do some extra work on the event based on the previous work, etc., etc. When you actually come to troubleshooting these things, again, like you've seen in all my other tutorials, it's a great way of helping yourself is to tail agent.log and grep on all caps error. And this line that you see here in the PowerPoint is probably one of the biggest things you'll get. An actual parsing, unexpected exception parsing map file, and then it'll give you the number of the file that's having problems. So it becomes pretty easy to track down issues that are actually going on. And you'll see here down the bottom half of the page, we're setting the device host name like we did in the previous example. We're basically pulling out just the device, the actual host name, and then discarding the domain name, or the domain suffix, so to speak. You'll notice that surrounding the entire regex token is a set of double quotes, and we need that. So that's a very good example of where you need to make sure that you've got quotes in the right place. When you're actually dealing with these things, you'll see things like loaded 5 map files successfully. That's a good indication that you've actually got things running properly. So again, make sure you're grepping and tailing agent.log for these sorts of things, it'll make life a lot easier for you. That's personally why I prefer to do my flex connectors and expression maps and so forth in Linux. It's just easier to tail and debug, in my opinion. Just recently in 7.1.3 of the connector framework, you could not set a field value that was already set. So in other words, you couldn't overwrite event.name or event.destination address if it was already set. Now I learnt this lesson myself the hard way when 7.04 came out, and I could only get particular fields to map, like device custom string and so forth. So that was quite annoying. But in 7.1.3 we've actually added the notion where you can control the map file operation, and here you'll see this is from page 132 of the Flex Connector guide, where you can actually set some flags for individual expression map files. And what this means is you can basically say, you start off with a exclamation mark, flags, then commas separate the different tokens that you're interested in, or the flags you're interested in. So in my case, where I wanted to overwrite event.name, I would have overwrite as one of my flags, so then I know I can explicitly overwrite event.name. So again, this was added in 7.1.3. So if you're using a connector framework before then, and you're having trouble mapping, there's a good chance you're just using a connector framework that doesn't support it. Alright, so just a few examples on paper here before we actually jump into an actual demonstration. So, for example, pulling the last two parts of a host name to get the domain name only. And what we're doing here is our first piece, even though it says set dot, is actually our getter. So we're getting out the source host name, and then dot event dot device custom string 2 is going to be basically the destination, or the setter, so to speak. The nomenclature is a little bit confusing, but that's basically what's happening. So we're getting source host name, we're setting device custom string 2. What are we setting it to? Well, in this case, we're doing a regex token against the source host name, and again, just like what you saw in the previous example, we're basically negating and getting rid of anything beyond the host name itself. So we're literally doing the reverse of what we did before. So you'll see dot star, and then we're basically getting up to full stops and grabbing everything you'll see there in the not backslash dot. So this, you'll see the extra parentheses in there. That's why we're grabbing that as our token. So again, anything in parentheses is the token itself, just like we've done in our other regex examples. And you'll see the double quotes in multiple places, because we need to quote out each and every piece of that. And then again, we've got the double quotes again at the very outer edges of this. And so the final outcome of this is that we end up with, for example, an Australian source host name looks to be some sort of a DSL account, maybe tpgi.com.au just becomes .com.au, for example. So we're getting the last two pieces of the FQDN. In this case, we might want to delete parts of the field, for example. You can see here where we're basically the name is in the event is blocked event, and what we're doing there is we're basically remapping it to just blocked. So we're basically deleting the second part of the token in event.name. So a pretty simple one, but it's it might be credit card numbers, it might be user names. You might just want the surname or something like that, as an example. Again, just like this, we might want to do some sort of a masking. This is a good example of where we're actually we're doing the regex token like we did in our previous example. So basically removing event, but then we're also doing a concatenation as a second. So underscore concatenate, and we're basically appending 5 x's to the end of it. So blocked xxxx. So there's an example of where we can mask, for example. Another example again might be credit cards. A couple more examples here largely the same sort of thing, but you'll see that I'm actually using two files here, 1.0, 1.0 and 1.1. So each of them are doing slightly different things. So in my first one, in 1.0, I'm actually copying to uppercase the source host name into device custom string 1. And in the second one, I'm actually doing just grabbing everything minus the host and copying it to device custom string 2. So in other words, between device custom string 1 and device custom string 2, I'm basically creating one field with the host and the other one with the domain. So I'm basically splitting them out, and that might be quite useful depending on what you're trying to do. So a couple of good examples there, and as you can see, I've got two files there. I could do map.12.csv, map.13, etc., etc. I myself have used a good dozen in the past to do all sorts of massaging and so forth, but they become very, very effective, and again, saves the need for you to have an unobfuscated text-based parser. Makes life very easy for you when you're out in the field. In terms of resources, make sure you've got the Flex Developer Guide. The latest one that's on Protect 724 right now is dated June 30, 2015. So it's rather important, and there's a fantastic Protect presentation by Mike Weston that goes through a lot of this stuff with map files. Really great stuff. You'll find that again on the Protect 724 website. If you haven't got an account, make sure you grab one. And obviously this is actually massaging and changing the integrity of the event. So if you do have a compliance requirement, this is obviously not going to suit you. You'll want to do something like preserve raw and then actually hash those raw events, and we can do that as well. And then with the rest of the event, you can then use expression maps on it. So at the end of the day, what we're doing here is making life really, really easy for you to remap, massage, and alter smart connectors and flex connectors out in the field. It's a fantastic way to just make those minor changes when you don't have access to complete text-based parsers. So with that, I will stop talking and move on to a demonstration. Alright, so here we are for the demonstration of a expression map. So what we're going to do is, as per the previous tutorials, take advantage of the flex connector we've already got built in. I'm actually going to use some FireEye logs because FireEye logs are good. They automatically come through in Ceph. FireEye is basically Ceph compliant, which is great. However, one of the things I want to do, and this is a perfect example of why you would use an expression map capability, is that if you look for file, the actual file path is set, the full file path. That's great, but what if I just want the file name itself? And that's what we're going to do here. We're going to say, okay, it's a Ceph formatted a log file. It could be syslog, it could be some other type of file reader and so forth. It doesn't matter. I chose this particular type because it was slightly useful and something you'd actually do out in the real world. So if we were to look at it again, we might look at CS6 is a full get on appliance-test.block.html. What if I just want to grab block.html, etc., etc.? So, there's a lot of different things that we can do here. Even though FireEye is Ceph compliant, I just want to make some minor changes to suit my own use case, to suit my own needs, and so that's what we're going to do here now. We're just going to grab that file and pop it into perhaps the file name path, for example. So let's go ahead and do that. Alright, so what I've decided to do is actually install a new connector. But what I'm going to do here is FireEye Ceph. What I'm going to do is create a Ceph file reader. So it's just a type of connector, smart connector. It doesn't have to be the log file doesn't already have to be in Ceph format whatsoever. And there she goes. All right, so I'm just installing an ArcSight common event format file. Got to find my file. There's the file that I'm interested in. Right, I'll send it up to my ArcSight manager. VM-ESM68C. FireEye. Okay, and I'll leave that as an application, and now we can start. We'll import the events and just see what they look like, and then we'll do the expression map. All right, while we're testing, remember one of the things we want to do is go into our agent.properties file and just make sure that we're starting at the end is false. That's good, perfect. And everything else seems to be in order. Alright, so if we actually run that Ceph file collector through the system and then bring it up into ArcSight ESM, you'll see, here we go here, first event from FireEye MPS. That's great. We're going to the console, and I've customized my view so I can just see what I'm interested in here, the file path. We've actually got a web infection here, and there's the entire file path there. So I actually just want to get that test-infection out of there and just into file name. That would be really useful, and then I could do comparisons on things like the top most seen web infected file, etc., etc. So there's a lot of value you could grab out of that. So let's go ahead and actually create that capability. So under user agent cd aup, we're going to create a folder called ACP, and then under ACP, as you remember from the slide deck, we're going to create our file. So we're going to go, let's just go vi agent info adder 1.map.10.csv. Right. Expression map to extract file name from file path. Then from here we can actually do our work. And when you're dealing with end of file stuff and parsing through lines to get through what you're looking for. So what we need to do is go to our .csv file, and as I explained before, we can insert these flags. It starts off with exclamation mark flags, then comma, and I want to be able to overwrite existing fields. Now if I wanted to disallow it, I would negate that feature. So I showed you that before in the actual Flex Connector guide, so make sure you take a read of that. So as you know, what we're wanting to do is basically extract the file name from the URL, from the file path, and send it to the file name. So our expression setter is going to be set.express, then the file path, so that's our getter, and then .event.filename is going to be our setter. So we're getting the file path and we'll be setting the file name. Now the question is, what are we setting it with? We're going to be setting it with a regular expression token where we're taking in the file path, and we're going to have to do a bit of regex to actually work out what it is that we're going to grab. Now the regex stuff usually takes a couple of goes. I've had a play with it for some time, and I've had partial success and so forth, and depending on how tight you want your regex, It might take you a few minutes, or if you're really, really good with regex, it might take you a few seconds. It took me a few goes to get it pretty much right, but I'm not convinced that it's actually 100% correct. There might be file names that mess it up a little bit, but for the purpose of the exercise, my regex was going to be dot star, and then basically escaping the forward slash. So in other words, looking for a forward slash. So everything up to the forward slash, and then in the token, the actual token itself, we want it to be everything after that forward slash. If you want to make it a little bit tighter, you can put the dollar sign at the end as well, and that basically asserts the fact that we're at the end of the line. So that helps the regex edge in some regard. So if you want to test it, a really good way to test it is to bring up the regex tool and actually just try it, see what happens. And when you save the file, so we've got the event here. So I've already opened it up, and we look for file path. There it is there. So let's delete everything around it. So we're just dealing with it. Okay, so there it is there. Right. So if we ask it to generate now, and then save it, it's basically saying, hey, I'm just going to create you a very simple regex with all non-white space characters. So not much use to us. Let's get rid of that because that's the actual field name itself. But if we were to actually do something like dot star, and you'll see it's all yellowed out, great, and then escape the forward slash, great, so we get to the actual file name itself, and then we want to tokenize the actual file name, great, and then dollar sign on that. And now you'll see when I actually hit save, my first common element becomes just the file name. Fantastic. So in theory, I could actually tokenize that part of it as well and get the actual URL minus the file name in that way if I wanted to. So there's another way of doing it. So we know that regex is going to be pretty close. It's not bad. There may be, if you have a think about it, there may be situations where that regex is not tight enough, but we'll leave it at that for now for the purpose of the exercise. So we've got that, we'll save it, we'll run our agent again, we'll go to our log tail, just see whether there's anything going on in terms of errors. One of the things you can do with grep is actually go grep error and then minus b and then the number of lines before, and minus a, the number of lines after you want the error to be displayed. So you can grab the lines before and after. That's a really handy thing for debugging. Now if we come over to the console, you'll see file path, that's the entire thing, and then file name has been extracted correctly. So what have we achieved here? We've basically achieved through a single 2-line file that we've added to a standard smart connector. So we haven't had to write a flex connector, we haven't needed to do anything fancy. We've simply written these two expressions here, our getter and our setter, and we've given ourselves a really useful addition to what the FireEye output gives us. So now we can use that file name in other processing, whatever that may be. So I hope you've found this useful. We've got more and more tutorials coming up, and I hope to see you next time. Thanks for watching.